Hello everyone, my name is Sharon Salmon and I'm a senior software engineer, and today I want to show you about indexes, specifically in Microsoft SQL Server indexes, but that can be indexes for any SQL server, relational database, and I want to show you how much it can improve the performance of your database. That's pretty amazing. So let's open here MS that browse this database that I have, the demo database. And what I want to show you here, I have some pretty complex query and some stored procedure that takes information from what's called statistic trace sample, and just look at it. It's about 8.5 million records in this statistic trace sample. Now I need to get some information out of it, that it is between some minimal time and maximal time, also with some intersected by some criteria, and of course I group it by some criteria which called tray ID, and I want to get only the latest of these trays. So this is pretty simple. Then I need to also join it with some information, so eventually I also get some information from some different table which shows the hatchery ID. Never mind currently the business, just important to see that it's pretty intense query. And here have some code that runs this store procedure. Okay, so if we look at this screen, we can see that it's about 350 milliseconds. Let's run it a couple of times, and we can see that it's always around this number. So now let's go and try to improve it to see how can we improve it by indexes. So let's take this select query and see what it selects by. So it selects by sample time twice and selects by flock ID. So let's go now to the index, and we'll add some non-clustered index. Forget about the cluster for the moment. Let's call it just test 111 just for this thing, and we'll add it. So we said we'll add the flock ID we need and the sample time, but the sample time I think needs to be up. You know what, let's try it first like this and see how it works like this. So let's try it. We see that it didn't improve very much. Okay, let's try to switch it. So the order may be important also, so we'll move it up. So now, and that didn't help too. Okay. So now we're going to try something else, and what we'll do, not only sample time and flock ID, let's try maybe to index it by the tray ID as well. Let's see if that will help. So we'll add the tray ID at the end. And we run the query. It didn't improve too much also. So let's do something more than that. In the non-clustered, we can also select fields that we want with the index. So we'll select the statistic tray ID field as part of the index. Let's go and do that. So we'll go to included columns and we'll add the statistic tray ID. Now that's important because what it does, it keeps with the index close to it this field, so it doesn't need to go to the record and fetch that field. We just do it automatically. Let's see how that helps. So we add it, and now let's try it. Oh, that didn't help. Let's try something else. Let's try to remove the tray ID. I don't think we need it. And let's try it again. Then. Actually, now I see that on the select from the statistic sample, I select not only the statistic tray ID, but also the tray ID, the start time, and the sample time. So let's add them to the index and see if that improves. So I'll go to the columns and add the tray ID. I'll add the start time, and the sample time is already indexed, so I don't need it. Okay, and let's see now how that improves. So over here, and that didn't improve. It actually, it's even worse, so I wonder. Let's see what happened. If I look here, oh, I forgot the battery, and I forgot the hatchery ID. That's from the join, but from the statistic tray sample I take also the battery. So let's go here and add the battery. So I'll go to the columns and add the battery. Let's find it. Here it goes. And now let's check it. Oops, let's try it again. Oh, that's not so bad. Let's try again. 90. That's more than 3 times faster than what we have. 3 to 4 times faster. Now that's an improvement. Let's see if we can improve more. So what we see here, that the first join, we do actually a join on the statistic tray ID, but we didn't index on the statistic tray ID. So we selected it, but we didn't index on it. So let's maybe add another index. This time we'll do a clustered index. We can, it's the primary one. Let's just leave it that name that it had for the, and we'll give the statistic tray ID. It will take some time to build. Okay, now let's try it. Ooh, that's nice. Oh, 27. That's not bad. That's more than 10 times faster. Now that's nice, but that's not excellent. We want excellent. So remember, we started about 300, around 350 milliseconds, and now we're in 27 milliseconds. Let's see if we can do it faster. Let's take a look at it again. Now I have some trick. Instead of using the with statement, what I'll do, I'll create a table in memory and fill it with this select. And let's see how this improves. So I already have here ready some code here of the table that created, and it's pretty much does the same. Let's copy it. Oops. Let's copy it. And I'll put it just below here. And I'll mark this out. Just to see. Okay, so we have the same code, but now we put it in a temporary table and we join on this table. Let's recompile the store procedure. And now, are you ready? Let's go here. Better. Oops. 0. Do you see this? 0. That means that we are below 1 millisecond. How much below 1 millisecond? Let's try to run it 10 times. Three milliseconds for 10 times. That's 0.3 milliseconds. So we started at 350 milliseconds and ended at 0.3 millisecond. That's like about 1,000 times improvement. Okay, so we learned here how to improve a query by 1,000 times faster. Think of it. That's like making something that took you 3 years in 1 day. Not bad. Thank you for watching. So to summarize, in this lesson I showed how with using indexes and with using in-memory table, how we can speed up a query, and we speeded up a query that took 350 milliseconds to about 0.3 millisecond, which is like more than 10,000 faster. I hope you enjoyed, and see you next time.